Hello and welcome to the Run the Linux OS Workloads with OpenNebula screencast. In this screencast, we are going to cover the most convenient way of running and adjusting Linux OS-based virtual machines in the OpenNebula ecosystem. OpenNebula distributes Linux OS-based images via the public marketplace. These images are ready to use with OpenNebula and can be launched without any adjustments. In order to run virtual machines, you must have a virtual machine template, the blueprint for the further virtual machines. Images that are coming from the OpenNebula marketplace are bundled with the ready-to-use virtual machine templates. These can act as a base for your custom templates or used as is. OpenNebula contextualization packages are enabling the virtual machine management capabilities that OpenNebula offers. These packages are pre-installed on every operating system image that is distributed via the OpenNebula marketplace. Should you build an image yourself, you will need to install the context packages as well. Images from the marketplace can be adjusted and turned into your customized golden images that are going to contain your own custom software, operating system hardening, tuning, and other necessary customizations. Import the desired Linux operating system image from the marketplace. If needed, adjust the memory, CPU, vCPU, and other virtual machine features. Note that some of them can be overridden during the instantiation process. Instantiate the virtual machine template for either further usage or to create a custom golden image. Install the software, fine-tune the operating system, or perform other necessary adjustments. Save the disk with the operating system as an image for further usage. Firstly, navigate to Storage, Apps, and use the search bar to locate the Ubuntu 2404 image. In the scope of this demonstration, we are going to use the Ubuntu operating system. However, you can choose whichever suits your particular needs. Press the import button to import the image and make sure that the export associated VM template/images is toggled. This will ensure that the necessary virtual machine template is going to be imported as well. Select the data store that is going to store the image at rest. The data store must be of the type image. An image is a snapshot of a disk, so its actual size may vary. It takes time to download while the virtual machine template is already there. Let's navigate to the templates, VM templates, and make some adjustments. Press Update to update the virtual machine template. Let's set memory to 4 and proceed to the next step. Let's also resize the disk. I'm going to set it to 30 gigs to have enough disk space during the software installation. You can keep it as is and resize in the future. To install the necessary software and also connect to my virtual machine, it must be able to network. By default, the template has no network cards attached. I'm going to pick one that is routable and can access the public network. As the last step, I'd like to set some customization, such as the default user with sudo permissions and the host naming pattern. Additionally, I'm going to set the command that is going to get executed every time a virtual machine boots up. Contextualization package supports much more settings to configure. For more information, take a look inside the official OpenNebula documentation. Once the template has been saved, let's instantiate it. I'm going to set the custom name Ubuntu VM and keep the rest on their respective defaults. Once the virtual machine is up and running, we can verify it using the VNC connection. Now it's time to implement the customizations. You can use either of the options, VNC or direct secure shell connection. I'm going to log in as OpenNebula user, the one that was defined using the context custom variables. To verify that our image is altered, I'm going to install the Nginx web server. Note that I'm not executing apt update because this was handled during the VM start using the start script functionality. Additionally, I'm going to disable IPv6 as a part of customization and system tuning process. Finally, the Nginx is placed into the systemd automatic startup process. Now we stop the virtual machine by expanding the VM state drop-down menu and selecting Power Off command. Once the virtual machine has been powered down, navigate to Storage, locate the disk with the operating system, and press Save As icon, the one that looks like the floppy disk. The virtual machine is going to go into the hot plug Save As Power Off state. Since the machine with the name Ubuntu VM is no longer needed, and in order to avoid reserving the resources for it, terminate the virtual machine using the trash bin icon. In order to avoid messing up with default virtual machine template and to indicate that this virtual machine is having some customizations, I'm going to clone the default template. Since we already have an image for this template, there is no necessity to clone the virtual machine template with an image. Now edit the virtual machine template. The only section that needs to be changed is storage. Substitute the Ubuntu 2404 disk with a newly created one. In order to verify that VMs are running the custom image, let's instantiate two virtual machines in a single batch. This time I'm going to name it as nginx-$IDX, where IDX is going to be the sequential number of a virtual machine within the batch, and set the number of instances to 2. The virtual machines are in the deployment process. Let's wait a bit until the status light turns green. Once both VMs are running, open the VNC by clicking the VNC icon to verify that there are no boot errors. And now let's connect to the IP address of the Nginx-1 VM to verify that the Nginx web server is serving the default web page on the port 80. Let's perform the same test with another deployed virtual machine. With this, we can verify that the golden image was built successfully and contains all the necessary adjustments. Thank you for watching and see you in the next screencast.